Okay, so today we're going to be starting to talk about trigonometry. So we've done the Pythagorean theorem. We've talked about special right triangles that are isosceles, where the two legs match. And then we've talked about 30, 60, 90, where all three sides are proportional to each other using S, 2S, and S root 3. So today we're going to say, you know what? Even if they're not 30, 60, 90s or 45, 45, 90s, the sides are still special to each other if you have a right triangle. And so we're going to be learning something called sine, cosine, and tangent, and how we can write fractions about any right triangle. And the fractions are called sine, cosine, and tangent. But before we do that, we need to talk about, what are the names of the sides of any right triangle? Well, you already know some of them, okay? You know, in a right triangle, the side across from the 90 is called the hypotenuse. Okay, so that's the first thing you do know, okay? And the thing is, of any right triangle, the longest side, the side across from the 90, is always hypotenuse. And so now you also know in a right triangle, there are two legs. And so there are names that we're going to call them. Okay. And we could call them lots of names, but the two names that we're going to use would be the adjacent leg and the opposite leg. And so they're saying if you are standing at A, okay, because where you live in Olathe, who lives right next to you is different than if you live in a different part of Olathe. So adjacent means close. Opposite means across. Okay, so who lives across town versus adjacent close to you are two, depends on where you're standing. So on a right triangle, I'm going to always tell you stand at one of the two acute angles. So I'm going to say stand at A, and I'm going to put a theta there. Okay, theta is the name of an angle. Okay, and we call it theta. Okay, so I'm just going to place that. I'm like, okay, if you're at A, okay, and if that's the angle we're speaking about, the hypotenuse doesn't change, but adjacent means touching right next to. So this is the adjacent leg because it's right touching that angle. The two sides that make it would be the hypotenuse and the adjacent leg. The leg that's not touching that angle, who's across from it, is going to be called the opposite leg. Okay, so the hypotenuse is going to always be the hypotenuse, but the legs are what we call them is dependent upon where we are standing on the triangle. So if this is the right angle, the hypotenuse will be here. And they said stand at B. Okay, so if your angle theta or your angle that you're standing at is B, what leg would you call CB? Well, CB would be the adjacent leg. Why would you call it adjacent leg? Because it's the one of the sides that makes that angle. The two sides that form the angle are the two adjacent sides. One's the adjacent leg and the other one is adjacent. We just call it the hypotenuse. The leg that would be across from it, not touching, this would be the opposite leg. Okay, so a right triangle always has two legs. The one that's close to the angle, forming that angle, is going to be called the adjacent leg. The side that is across from it is going to be called the opposite leg. And so the deal is that as we are doing trigonometry, you kind of have to say, well, where are we standing? What are the names of the sides based on my location? So on this triangle here, we're going to say, assume this is where you're standing at that theta. Okay. So the sine of theta, sine is going to be written, okay, you abbreviate as SIN because sine has four letters and the button on your calculator has just room for three. And so we call it sine, but it is just written sin. Okay. And so to do that, we do the opposite leg over the hypotenuse. So the length of each. Okay. So let's look at this and say, okay, compared to theta, C is the hypotenuse. And you see there's two legs that meet at the right angle. The side that's opposite that theta, okay, not touching it, would be side A. Around us. And this would be adjacent. Can you see that the two sides of the triangle that form the angle are both adjacent, but the one is the hypotenuse and one is the adjacent leg. So if I say, what is the sine of theta? Okay, if you stand at theta, you have to write the opposite leg over the hypotenuse. So that would be the side A, whatever, how long that is, over side C. Okay, the length of side C. And normally they're numbers that you'd write, like, oh, 5/7 or something like that. But this is just going to be visually A over C. How long A is over how long C is. Cosine is going to be written, and it's abbreviated like this. That's the adjacent leg over the hypotenuse. So you write the length of the adjacent leg, which is B, over the hypotenuse. So it would be B over C. And then the last ratio we're going to be talking about would be tangent. And we just write tan. Okay, so tangent of theta would be the opposite leg over the adjacent leg. So this would be, in this case, A over B. And normally they're numbers, but it would be A over B. So we have to learn like what those fractions are. If I ask you what sine is, you have to be like, oh, I'm going to do the opposite over the hypotenuse. And this actually is something you're going to do this year. You'll do it a little bit more in Algebra 2, and then in college algebra or pre-calculus, or if you get to calculus, absolutely you'll do more with trigonometry. Okay, and so SOHCAHTOA is basically the foundation of trigonometry. So the SOHCAHTOA is an acronym to help you to learn these three trigonometric ratios. So that means means if you want to find sine, that's going to be OH, opposite over hypotenuse. Cosine is the adjacent, CAH, adjacent over hypotenuse. And then TOA would be the opposite over the adjacent. So you have to know SOHCAHTOA or know what sine, cosine, and tangent are all going to be. Okay, excuse me for 1 second. Okay, I'm back. So SOHCAHTOA. So sine is OH, opposite hypotenuse. Cosine is AH, adjacent over hypotenuse. And TOA would be opposite over adjacent. So you do need to know SOHCAHTOA. And so I wrote it like 3 times in a row. Okay, so the next thing we're going to do is we're going to say, here is a right triangle. And we're going to take turns of saying, okay, if you stand at L, and if I put theta right there, okay, if I stand at L, okay, let's name the sides based on L, okay? You don't have to write theta there. I'm just doing it as a placeholder. So we're standing there. Well, 13 is the length of the hypotenuse because that's across from the right angle. And we've got 2 legs. Which one is the adjacent leg? Remember, the 2 legs that form the angle that we're standing at are going to be both adjacent. And so this would be the adjacent leg, and this would be the opposite leg compared to a side angle L. Okay, and so the hypotenuse is still 13. It's the longest side, it's across from the 90. The leg that's closest to the angle is the adjacent leg. The opposite, when across town, across the triangle, not even touching the angle, is going to be the opposite leg. So the ratio of the sine of L, okay, so sine is O over H, opposite over hypotenuse. So that would be 5 over hypotenuse, which is 13. Should always reduce and rationalize your answers as you can. In this case, 5/13 does not reduce, but it says give me the decimal as well. So 5 divided by 13 on your calc would be 0.38. Okay, and a lot of times we just leave it as a fraction. Cosine from L's perspective is the adjacent over the hypotenuse. So that would be 12 over 13. And 12 divided by 13 on our calculator is 0.92. And then tangent of L's perspective is the opposite leg over the adjacent leg. So the length of the opposite leg would be 5. The adjacent leg would be 12. And if you divide those, you get 0.42. So just stand at that angle and then answer the ratio of those sides. Now what they're going to say is stand at the other angle. And then we don't always do that, but sometimes we do. So if we say, okay, what if you stand not at angle L, but stand at N? right here. Well, the hypotenuse stays the same. However, and I can put this theta here just because it's cute. The adjacent leg is going to have a length of 5, because remember, the leg that's closest to the angle, it makes that angle, is going to be the adjacent leg. And if you recall, the name of the other leg is going to be the opposite leg, the leg that doesn't touch it. It's across the triangle from that angle. So the ratio for sine from n's perspective would be SOH. So sine is opposite over hypotenuse, so that'd be 12 over 13. And if you divide that, you're going to get 0.92. Cosine from n's perspective would be the adjacent leg or hypotenuse, or 5/13. And that would be 0.38. And then tangent from n's perspective would be the opposite leg from angle n, which would be 12 over 5, and that would be 2.4. So now it's going to ask you, do you notice anything? Okay. The patterns I see are this. Do you see that these are kind of interchanged? The sine of L equals the cosine from N, because from one side of the triangle, the adjacent is different from the opposite from the other side of the triangle. So cosine from one angle's perspective is equal to the sine of the other angle's perspective. So you could do the opposite and be like, sine of N equals the cosine of L. And then also tangent are reciprocals. So tangents of L and N, because again, it's the opposite over adjacent for each perspective. But if you stand at the other side of the triangle, then the opposite and the adjacent side or legs are going to be interchanged. So we're not going to make a big deal about it, but that is absolutely true. Can the sine or cosine ratio ever be bigger than 1? And the answer is no. Why? Because it's a leg over the hypotenuse, and the leg is shorter than the hypotenuse. So your sine and cosine will never be bigger than 1. Tangent could be, okay, but sine and cosine are never going to be bigger than 1 because they're a leg over the hypotenuse. Okay, so now we're going to go to kind of talk about some other features. I'm going to change this to skosh. I'm going to say, you can find trigonometry of like special triangles. And I kind of want to point out something, and then I'll show you how you will actually do it. So if we, actually look at a 30, 60, 90 triangle and kind of practice what we've done before, and we say, hey, this is 2s, this side across from the 60, that's or 30 is s, and this is going to be s root 3. They give us the hypotenuse, that means s is equal to 10. So that means that this side here is actually 10, and this side would be 10 root 3. So I'll highlight the length of each side. So this is 20, this is 10 root 3, and this is 10. And so, we could do the same thing with the next triangle. Across from the 60 is going to be s root 3, this is going to be 2s, and this is going to be s. And so that means that this side here would be 2 times 42, or 84, and this would be 42 root 3. And then even more abstractly, if we just write the ratios on here, like, okay, this right here could be s or x, and then we could call it s, it doesn't matter. This could be 2s, and this would be s root 3. And I'm going to change this to say, okay, what is going to be the sine of 60 degrees? Okay. So let's go to the first triangle. So sine is the opposite over the hypotenuse, right? So sine of 60 degrees, the opposite leg of the 60 is going to be 10 root 3. The hypotenuse would be 20. And so if we reduce this, okay, by looking at the coefficients, it can divide them both by 10, and you're going to get square root of 3 over 2. So that's going to be the sine of 60 degrees on the first triangle. On a second triangle, if you do the sine of 60 degrees, you're going to do the opposite of the 60 degree, which would be 42 root 3, over the hypotenuse, which would be 84. And if you reduce those coefficients, you're going to get the square root of 3 over 2. You can divide top and bottom here by 42, and you're going to get 1/2. And the last one, if you do the sine of 60 degrees here, if this is 60, then you do the opposite leg, which is going to be s root 3 over the hypotenuse, which is 2s. Now, one thing that's weird is that the s's cancel out, and you get the square root of 3 over 2. What do you notice? They're the same. Why? Because they're dilations of each other, okay? And the thing is this, what is the square root of 3 over 2 in your calculator? Okay, let's do that. Let's see. I take out my calculator and I clear this out and I go, what is square root of 3 over 2? I'm going to get 0.866. Dot, dot, dot. And then it says, why don't we use our calculator to figure out what the sine of 60 degrees is? Well, the first thing we have to do is to go into mode and make sure we're in degrees. And so we should arrow down here, arrow over, push enter. There's two different ways to measure angles. One is radians and one is degrees. At this point in our lives, we're going to use degrees. Okay, that's kind of what we're comfortable with. So you have to push mode and change your calculator into degrees. And so then we're going to do second quit. And if we ask our calculator, what is the sine of any 60-degree triangle? Guess what it's going to tell us? 0.866. And we saw that on the top 3 questions say whether we use specific values of a triangle and do sine of 60, or we ask our calculator, or we just do the general ratio formulas. The sine of 60 degrees will always be the square root of 3 over 2. And all of the special all the values of sine and cosine are always going to be the same, okay, because they're dilations of each other, okay, they're proportional to each other. So let's practice kind of doing this kind of with our mind and saying, okay, we can put right here 0.866. Okay, so let's look at a special right triangle of 60, 30, 60, 90. And this is going to talk about 30 from the 30 degrees perspective. Okay, so let's write the ratios on here. So this is S, this is 2S, and this is S root 3. We don't know any specific values, so we'll just write the ratios there. And then also from the 30 degrees perspective, this is going to be the hypotenuse. This is going to be the opposite leg. This is going to be the adjacent leg. If you want to do the sine of 30, that's going to be is opposite of hypotenuse. So let's do the opposite leg from the 30, which is going to be S over the hypotenuse, which is 2S. And you can reduce that, okay? It's kind of like 1S over 2S. The S's cancel out. You get 1/2. If you ask your calc, what is the sine of a 30-degree angle? You're going to get 0.5. So your calc knows it too. The cosine from 30 degrees, so that'd be cosine ka. Cosine is adjacent over hypotenuse, so that would be S root 3 over 2S, pardon me, the hypotenuse. The S's cancel out, and you get the square root of 3 over 2. If you asked your calculator what the cosine of 30 degrees, they'd give you a decimal, but I want the exact answer. And then tangent from 30s, tangent is going to be opposite over adjacent. So the opposite leg is S, the adjacent is S root 3. Okay, so here's where we got to be a little tricky. We have to reduce and rationalize. So the S's cancel out. You're left to the 1 on top. You do need to times top and bottom by the square root of 3. You get the square root of 3 over 3. Square 9, which is 3. So here are 3 answers to this question. So when I ask you, oh, tell me sine, cosine, or tangent of any angle that's special, you write the ratios and then answer the question. And so like for 45s, well, I can't do sine of 45. So I'm going to write the ratios. That's S, and S root 2. So from 45, now it doesn't matter which one you stand at. So let's do this one right here because they're both 45. So just pick one to stand at. And you're like, okay, obviously this is the hypotenuse. This is the opposite. This is adjacent. So sine is the opposite leg over the hypotenuse. So that would be S over S root 2. Okay, we're going to need a little space to do this one. The S's cancel out, and there's still a 1 up there. So we're going to rationalize it by timesing top and bottom by the square root of 2. You get the square root of 2 over the square root of 4, which is 2. So that's going to be my answer here. The next one is going to be the adjacent leg over the hypotenuse. So that'd be S over S root 2. The S's cancel out. You're left with the 1 on top. We have to rationalize it. You get the square root of 2 over the square root of 4, which is 2. And then notice sine and cosine, since the legs are equal, you get the same thing on 45s. And then tangent would be the opposite over the adjacent. So TOA, opposite over adjacent, S over S is just 1. Okay, tangent of 45 degrees is just going to be 1 because the ratio of the same numbers. And then the last thing we're going to do is say, your calculator is smart. Can you do these values on your calc and say, okay, can I do the tangent of 78 degrees? And give me a decimal. The answer is going to be 4.70, okay? And then sine of 28, 0.47, cosine of 72, and that's going to be equals 0.31. And then the last one is the tangent of 23. So if I don't give you a triangle and say use your calculator, you can use your calc to say, okay, 0.42. So that's, one of the beauties is your calculator knows that if you've got a 23-degree triangle, no matter what the length of the sides are, tangent will always make the same fraction or decimal, okay? Because all 23-degree triangles are proportional to each other. And so I think there's 3 different things that we learned today. One is SOHCAHTOA. The second thing is you got to start by standing at a certain angle and saying, okay, based on that angle, do I know what to name the sides? Which one's the hypotenuse? Based on that angle, who's the opposite, who's adjacent? And then can you answer SOHCAHTOA based on whatever angle you're standing at and based on the numerical lengths of those sides? So sine from, in this case, n's perspective would be the opposite leg over the hypotenuse. So it'd be 12/13. Cosine would be the adjacent leg of that angle over the hypotenuse. And tangent would be the opposite over the adjacent. So you need to know SOHCAHTOA and then how to write those fractions. The next thing you need to know is, what if I give you a special triangle like 30, 60, 90 or 45, 45, 90? Do you know that you write the ratios and then you have to stand out whatever angle I talk about and say, can I write those ratios and then reduce them and rationalize them? Okay, so that's going to be a good practice. And then the last thing is, can you use your calculator to find the numbers of the values of certain sine, cosines, and tangents using your calculator. All right, that sounds incredible. I hope you have a great day.